Uh, okay, let us. So what we have done in lecture number 1. In the lecture number 1, we were given, for example, the parametric equations x equals to f of t, y equals to g of t. Okay, this can represent any curve in the xy plane. In the xy plane, it represents any curve. Okay, so there are 4 things we have done in, for example, how can we find the equation of the tangent line. The second thing was we discussed is how can we find the area under the curve, and the third thing was finding the arc length of the curve, finding the arc length of the curve. Okay, and the number 4 was finding the surface area of surface which is generated by revolving a curve around the x-axis or about the x-axis. Now, what is our main goal? Our main goal is to find, if a polar curve is given to us, how can we find the equation of a tangent line to a polar curve, area under the polar curve, and the arc length of a polar curve. So these are the topics we will discuss here in the next topic. Our first topic will be how do we find how do we find the tangent to a polar curve. Tangent to a polar curve. Again, remember one thing. Whenever we want to find the equation of a tangent line, okay, we need 2 things. We need 2 informations. The point, okay, the point through which the curve is the tangent is passing or touching the curve, and the second thing is the slope, which is given by m equals to dy by dx. So we need 2 informations in order to find the equation of a tangent line, the point and the slope, and then you can use this equation, y minus y1 equals m into x minus x1, and then you can substitute these values here in order to find the equation of the tangent line. Okay, so but first of all, now what we are doing here, we want to find the equation of tangent line the equation of a tangent line to a polar curve. Okay, and any polar curve, it is given by r equals to, let's say, f of theta. R equals to f of theta. Okay, so in order to find dy by dx, what we have to do, we need to find x and y, okay, in terms of the parameter theta, and then we differentiate them, and then we are going to find the dy by dx. So our first goal is the following. Remember from the above these 2 equations, okay, we have these 2 equations, x equals to r cosine theta, y equals to r sine theta. We substitute the value of r in these 2 equations. Okay, so remember this thing, x equals to r cosine of theta and y equals to r sine of theta, and we substitute this value of r in these 2 equations. Okay, and then what will be happened, we get two different equations, two parametric equations. X equals to f of theta multiplied with cosine of theta, and y equals to f of theta multiplied with sine of theta. Okay, so now these two are parametric equations in theta. Okay, these are parametric equations, parametric equations. And what is our parameter? Theta is the parameter. Theta is the parameter. Theta is the parameter. And what we have to do from this first equation, okay, from the first equation we need to find dx by d theta, and from this second equation we are going to find dy by d theta. And remember, this is a product. Here we have to apply the product rule in order to find these coordinates. Okay, in order to find these coordinates, dx by d theta and dy by d theta. So after finding dx by d theta and dy by d theta, we can find dy by dx by substituting these values here in this. So dy by d theta and dx by d theta, dx by d theta. Let us do an example with the help of this. So in this example, we want to find the slope of the tangent line when theta equals to pi by 3. When theta equals to pi by 3. Okay, there is one more thing we can do. You can also remember this formula. This formula which is given here in equation number 3. In equation number 3. I will write this formula one more time here for your convenience. For example, x equals to r cosine of theta. R equals to x cosine of theta. And remember here, r is a function of theta. So when we find dx by d theta, we will apply the chain rule. First we find the derivative of r with respect to theta. Cosine theta comes here as it is, and then in the second, r will come here as it is. And what is the derivative of cosine theta? The derivative of cosine theta, it is minus sine theta. And what is dy by d theta? It will be equal to dr by d theta. But first of all, I will write here y equals to r sine of theta. So dy by d theta, it's equal to dr by d theta sine of theta plus r, and the derivative of sine theta, it is cosine of theta. So let us find this here. Our r equals to 1 plus sine of theta. Okay, so remember here in this what do we have? We have dr by d theta. So first of all, we need to find the derivative of this r. with respect to theta, it will give us the derivative of 1 will be 0, and the derivative of sine theta, it is equal to cosine of theta. Cosine of theta. Cosine of theta. And the next thing we need to do, we want to find the slope of the tangent line at the point theta equals to pi by 3. Theta equals to pi by 3. Theta equals to pi by 3. So now what you have to do, you have to substitute everything first of all in this formula dy by dx. And remember, dy by dx, it is equal to dy by d theta. Dy by d theta. And in this dy by d theta, dr by d theta, it is equal to cosine of theta multiplied with sine of theta plus r. In place of r, we substitute 1 plus sine of theta multiplied with cosine of theta. Cosine of theta, and at the bottom what we are going to write, dx by d theta, which is equal to dr by d theta, it is equal to cosine of theta, and multiplied with again cosine of theta minus 1 plus sine of theta multiplied with sine of theta. Sine of theta. And now we substitute this point theta equals to pi by 3. And remember one thing, sine pi by 3. What is the value of sine pi by 3? And what's the value of cosine pi by 3? Pi by 3, it is the 60 degree. So sine pi by 3, it is square root of 3 by 2, and cosine 60, it is 1 by 2. We substitute these values here in this so what we are going to get, so dy by dx, and it is evaluated at the point theta equals to pi by 3. Theta equals to pi by 3. So it will become cosine pi by 3. Cosine pi by 3, it will give you 1 by 2 square root of 3 by 2 plus 1 plus square root of 3 by 2 multiplied with 1 by 2. This is a product, okay. Cosine theta, it is 1 by 2 multiplied with 1 by 2 minus 1 plus here we have theta here, 1 plus square root of 3 by 2 multiplied with square root of 3 by 2, square root of 3 by 2. And when we simplify this thing, okay, when we are going to simplify this thing, we will get the answer, it will be equal to minus 1. It will be equal to minus 1. So this is our slope, okay, this is our slope. Now in the next question, he is saying that we need to find the points on the curve where we have the horizontal tangent and the vertical tangent. So number B, the first thing we need to find the points where we have the horizontal tangents. Horizontal tangents. From the previous lecture, we know that we can find the horizontal tangent by substituting dy by d theta equals to 0, and that will give us the following. For example, if I put dr by d theta equals to 0, dr by d theta, it is equal to cosine of theta multiplied with sine of theta. And what is r? R is 1 plus sine of theta multiplied with cosine of theta. This cosine theta, it is outside, and we will put this thing equal to 0. And when we for example, when we simplify this thing, we can take cosine theta outside as a common factor, and inside we will get sine theta plus 1 plus sine of theta equals to 0. And from here this becomes cosine of theta multiplied with 1 plus 2 sine of theta. It equals to 0. And we know that the product of two numbers is equal to 0. Then one of them has to be equal to 0. So from the first one, either we get so that implies cosine theta equals to 0, or 1 plus 2 sine of theta equals 0. From the first one, we get two different values of theta. We know that cosine 90 is equal to 0, so that will give us two values, pi by 2 or 3 pi by 2. And from this second one, we get sine of theta equals minus half, and that will give us the following. And remember that sine is negative in the third and the fourth quadrant, so it will give you in the third quadrant, it will be equal to pi minus pi by 3, pi plus pi by 3, and in the fourth quadrant it will be equal to 2 pi minus I think this thing is here, pi by 6. So theta equals to, this becomes 7 pi by 6, and from the second one we get here 11 pi by 6. So these are the points where we are going to have the horizontal tangents, and similarly we can find the vertical tangents. And in order to find the vertical tangents, we will substitute, we are going to substitute, and in order to find the vertical tangents, we will substitute dx by d theta equals to 0. Dx by d theta equals to 0, and that will give us the following equation. That is, it will give us the following equation. Okay, it will give us the following equation. I will write it here. Cosine square of theta minus 1 plus sine theta multiplied with sine of theta equals 0, and that will become cosine square theta minus sine of theta minus sine square of theta equals to 0. And then what we have to do, we have to rewrite this thing in the following way. For example, this first cosine square theta, it can be written in the following way: 1 minus sine square theta minus sine of theta minus sine square theta equals to 0. Okay, and then it becomes 1 minus sine of theta minus 2 sine square theta equals to 0, and this can be rewritten in the following way: 1 minus 1 minus 2 sine of theta plus sine of theta. We are factorizing this equation in order to find the values of theta. So 1 minus 2 sine of theta, and from these two terms we can take sine theta as a common factor, and inside we will get 1 minus 2 sine of theta. So this becomes 1 minus 2 sine of theta multiplied with 1 plus sine of theta, and again it will give us two different equations. 1 minus 2 sine of theta equals to 0, and that will give us sine theta equals to 1 by 2, and from here we get two different values of theta. Theta equals to pi by 6, and also pi minus pi by 6, pi minus pi by 6, which is equal to 5 pi by 6. And the other equation, it will give us sine theta, this equation will give us sine theta equals to minus 1, and we know that sine theta equals to minus 1 at 270 degree, 3 pi by 2, 3 pi by 2. So these are the values where we are going to have the horizontal tangents and the vertical, the horizontal tangents and the vertical tangents. And you can look at the graph of this function. The graph of this function, it looks like this. It looks like this. So there are 4 points, 1, 2, 3, 4. There are 3 points where we have the horizontal tangents, 2 points where we have the vertical tangents, and this is the slant tangent.